Hello, we're going to take a look at 2.6, investments with payments, still earning that compound interest. Now, we've done investments before that earn compound interest, and we always do that with the TVM function on our calculator, but we've never had payments. And anytime we haven't had payments, we still have to fill in those indicated sections on our calculator, but we've filled out the sections PMT, PY, and PMT at the end with our default values. Our default values have always been 0, 1, and end. Now, this time round, we might actually have payments going on. Remember that payments are represented by any sort of repeated investment or with repeated withdrawal. If it only happens once, it is not considered a payment, but if it happens more than once, it is. So we are going to take a look at that. Remember that PMT kind of acts in the same way, sign-wise, positive, negative-wise, as our PV value does. So if I have some sort of deposit or investment, I'm going to have a negative value for my my PMT. And if I have some sort of withdrawal or loan, I'm going to have a positive value for my PMT. My number of payments per year will be indicated in the question, but similar to compound periods per year, that might not be indicated clearly as a number, but rather some sort of frequency like monthly or annually or semi-annually or bi-weekly, etc., which I will then translate into a number. Lastly, my PMT at the end part of my TVM values, I will continue under the assumption that the input value that I'm going to have there is end, unless it explicitly states that my payments are made at the beginning of the indicated time period. Now, this will give you a difference in your answer, because if I invest money, let's say at the beginning of every single month, as opposed to the end of every single month, so if I invest my money May 1st, it's going to be in the bank 31 days longer than if I invest that money on May 31st. So if it's in the bank longer, it's going to earn more interest. So it will make a crucial difference of when, at that time period that I'm investing that money, I end up investing it, at the beginning or the end. So we assume end unless otherwise indicated. All right, we are going to jump right into our first example. So if I decide to invest $250 per month in a bank that offers an interest rate of 6.25% compounded semi-annually, what will your money be worth in 5 years if the interest rate remains unchanged? All right, so I know that this is a TVM-based question because I know that I have compound interest here. And the only way that we've learned to deal with compound interest is that TVM function on our calculator. Remember, we're always going to tackle our end value last because our end value is dependent on number of years and PY. So until we figure both of those things out, we can't figure out end. So I like to do that last. All right, going through, we find out that we're investing $250 every single month. That is a repeated investment. It's not happening just once, it's happening more than once. So that's going into my PMT value. It's going to stay negative because it is, in fact, an investment. And my PY, because it's happening every single month, happens 12 times per year. There's 12 times I make that payment every single year. So the 12 will go there. I have an interest rate, and that interest rate is 6.25%, so that goes in the regular spot. I am compounded semi-annually. Semi-annually implies 2 times per year. And that's all the information other than the number of years kind of here given to me. Now I could use my number of years now that I have my PY to figure out my end value. Remember that my end value is PY times my number of years, which in this case is equal to 12 times 5, which is 60. Now we might be looking at this and going, hey, there's a few blanks going on. What's happening? Now the question says, what will my money be worth in 5 years? So what will it be worth after that time period I'm investing for? That means I'm looking for my future value. My PMT had no indication that I was investing at the beginning of every month, so that's automatically going to be end. Now what happens to PV? Now PV does not always have to have a number involved because my PV indicates like a one-time lump sum investment if I'm talking about investment, or withdrawals if I'm talking about a loan here. Now, because I don't have any initial investment, the only investment I have is a repeated one, I just say that there's no initial big deposit happening at the beginning, so my PV is 0. I'm going to plug this into my TVM. Feel free to pause the video to make sure that you know how to do it. Okay, hopefully you paused it. But we end up with $17,518 and 98904 technically cents, but we don't refer to money with that many decimal places, so I do have to round to 2 decimals. So I get this value here. And that is, in fact, my final answer. Okay, we are going to try the same thing with the next question. The next question is a 2-parter. So we have Zoe investing $1,500 in a savings account for her son Zen in the day he was born. Each paycheck, she invests an additional $50. The bank account earns 2% interest compounded monthly. If Zoe gets paid semi-monthly, how much money will be in the account when Zenon turns 18? Okay, so for part A here, we're talking about how much money is ending up in that account. And we are having compound interest there, so we are using TVM, and these are the values for the TVM input. All right, going straight into it, Zoe's investing $1,500 the day he was born. That is a one-time investment. She's not doing it every day, because who has that kind of money? But just once. So that is going into my PV spot. Okay. Each paycheck, she invests an additional $50. So she's investing $50 every single paycheck. That's happening over and over and over again. So that goes into my PMT. Reminder, it's negative because it is in fact an investment. Now, it says that she is doing this every single paycheck. So my PY would be based on how frequently she gets that paycheck. Now, there's some information between the $50 and when that's stated, but we're going to just jump ahead really quick. Zoe gets paid semi-monthly. So that means she gets paid twice every month. So if there's 12 months times 2, 24. So she's making that $50 investment 24 times a year. So PY is 24. All right, the interest rate is 2% and it is compounded monthly. So 2% for a percent and compounded monthly is going to give me a 12. And we know that she is going to have that money in for a total of 18 years because it's from the day he's born until he's 18. So when I'm looking at my N value, PY times number of years, that's 24 times 18. And you can actually plug this straight into your TVM spot. It will do the calculation once you hit enter, but that gives me 432. I'm looking for my FV, and there was no indication that she's making that payment at the beginning of every half month. So we have that assumption that the PMT is going to be end. We go ahead and plug this in, and like I said before, pause the video, plug it in, see what you get. After I do all that rounding, I get $28,134.17. And that is my answer to A. But there's more to this question. The second part asks how much interest will Zoe have earned on her investment at the end of 18 years. So, we are taking a look at the dollar amount of interest Zoe will have earned on that investment. So things that we need to know what that investment ends up being, which we do from part A of this question. The other thing we need to know is the total amount she ended up investing, right? Because that difference is what that interest earned is going to be. Now, we're not just looking at the original question here and saying, oh yeah, PV's $1,500 and then $50, so that's $1,550. That's how much you invested. That would be inaccurate because the payment's happening over and over and over again. So instead, we need to figure out how much he actually invested. So I'm going to do that calculation here. Oops. total dollars invested. And there's no official formula for this. I like to kind of make one up. But how this looks like is we take a look at the original amount she invested, that $1,500. And it's not negative here because the calculator needed the negative to tell me the direction of the money. But in real life, that money isn't a negative value. So that original amount of $1,500 plus she invested $50. How many times? Well, N times. N represents my total number of payments. So if she makes a payment of $50, we need to say she makes that payment 432 times. I didn't really need to have the brackets there, but that's what I've got. And I could do that calculation. So I could say, well, that's $1,500, beep, boop, bop, plug that in and get $21,600. And then I could add that further to say that's $23,100. But that's how much she totally would have invested over the span of those 18 years. Much higher than what originally we might have thought just by looking at those original numbers. Now again, this isn't what the question asked. The question asked what the dollar amount of interest would be. Now the interest she earns, interest in my dollars, is equal to the difference between what she ends up with and what she totally invested, the total amount of money that she invested. So she ends up with, or I guess Zenon ends up with, $28,134.17. And Zoe, Zenon's mom, invested a total of $23,100. The difference between these two values here is $5,034.17. So that is the total amount of interest in dollars that would have been earned in this savings account. All right, now I told you before I kind of make up a formula when I'm talking about the total amount of money invested. This number here, if I'm talking about investment, I'm not talking about withdrawal or a loan or something like that. But this number, that 1,500, comes from my PV. Now, I am also adding in my PMT, my N. Now, N is the number of payments. PMT is what my payments are worth. So when I multiply that together, that's my total amount invested when I'm talking about my repeated investments. I add that to whatever original lump sum I had at the very, very beginning, and that's my total amount invested. Now, this formula will work every single time to tell me my total amount of money invested. It's just not an official formula. It's just something that you can follow, but logically speaking, hopefully we can get through to the total amount invested with or without it. It's not something completely necessary. All right, we are going to take a look at another example, and this next example compares the following pairs of investment over a 2-year period. So we have a bank that offers an interest rate of 10% nuts per annum, compounded monthly. And we want to determine the future value of each investment if, in option 1, we invest all that money, $2,400 at once as a one-time lump assessment or investment, or if we invest $200 at the beginning of each month. What I'd like you to do, I'd like you to pause the video, try and plug in these values, see what you get, and then unpause and see if yours matches mine. Go. And welcome back. All right, so I'm going to take a look at the first one here, and I'm going to go through it relatively quickly. I know that my interest rate is 10%. I'm investing my money all at once, so that's negative $2,400. There's no talk about a repeated payment, so my PMT is 0, my PY is 1, and my PMT is end by default. I know I'm compounded monthly, so this gives me a 12. I'm looking for my future value, so that's a question mark. And my N value is equal to my PY times the number of years, which is 2, to give me 2. When I plug this into my calculator with appropriate units and rounding at the end, I end up with $2,928.94. When I take a look at option 2, I still have the exact same interest rate. I'm not making a one-time lump deposit, so I have a PV of 0, but I am investing $200 at the beginning of each month. So I have negative 200 in my PMT. You have begin at the last PMT at the bottom there, and PY is 12. I'm still looking for my future value. My compounding period does not change. It's still monthly. And now my end value is equal to my PY, which is 12, times my number of years, which is 2, which gives me 24. Oops. When I plug this in, my future value with appropriate units and appropriate rounding is $5,333.46. Now, there's a follow-up question, and the follow-up question says, which of the two options above is the better choice? Now, we can't just look at that and go, hey, obviously option 2 is better. I end up with more money. Because it is not necessarily better just in terms of your final amount, because what if I invested most of that money and made very, very, very little interest in comparison? So when I don't have identical deposit schedules, so I'm not investing the same kind of amount in the beginning or not investing the same kind of amount repeatedly, and within the same repetition period there as well, I can't do that direct comparison. Before, we learned about rate of return. Rate of return is a really good option to kind of bring both of those investment types into a more standardized format so we can figure out what would be the better choice in investment. So I'm going to split this page into 2 here, and I'm going to do the rate of return for both of these. So for my first option, for my rate of return, remember that my rate of return, my numerator is the dollar amount of interest earned. And I can figure out that dollar amount of interest by saying what I ended up with, in this case, $2,928.94. Subtract the total amount invested. Now for option 1 here, the total amount of invested is very obvious because it's not a repeated payment. It's a one and done. And then I divide by that total amount invested, that $2,400, and I times it by 100%. I'm going to go ahead and do that calculation, and you should plug that into your calculator as well. I could do it step by step, and as if I do it step by step, it becomes more obvious to me what that dollar amount of interest is. That's this value here. That's my dollar amount of interest earned on my first option. And when I plug that in and round to 2 decimal places, I get 22.04% rate of return. Now, we can't look at something and automatically say the rate of return is super great just by how big the number is. Oftentimes, that rate of return will also depend on the number of years invested. Because this is over the same period of time, we can directly compare those numbers. If we had 2 different periods of time, we would have to look at something a little bit different. Instead of rate of return, we'd have to look at annual average rate of return. But we're looking at an investment over the same 2-year span, so we don't have to worry about that now. All right, so for my second option, that rate of return is going to be a little bit more challenging to calculate because I don't have an obvious amount that I've invested so far. Now, I'm going to figure out that total dollar amount invested before I plug that value into my rate of return formula. And just like before, we said that was PV, which in this case is 0, plus my PMT, which is 200, times my N value, which is 24. Now, this still works out in the same way, even though that I have a PV of 0, won't make a difference, but the total amount I've invested here on this second option is $4,800. Now that I have that amount, we are able to calculate the rate of return. The rate of return is the amount that I end up with that $5,333.46, subtracting the total amount I've invested, and dividing by that same total amount invested, and multiplying that final answer by 100%. Same as before, we can do this calculation piecewise. Go ahead and just calculate that numerator first. And the only reason that I'm showing us here is not necessarily because I expect you to show me this on a test, to show this extra step, but just to show you that that numerator is really just the dollar amount of interest. So how much interest did I earn on that second investment, that second option? Well, I've earned $533.46 worth of interest. Of course, that's not what I'm looking for here. I'm looking for my rate of return. Plug that into my calculator. Round to 2 decimal places. Ensure I have my appropriate units, and I get 11.11%, 11.11%. Now that both investments are over a same 2-year period, I've calculated the rate of return for both. Now I can directly compare the two to determine which one's better. The one that's better is going to give me the higher rate of return. So, of course, I need to state that somewhere. So I'm going to state that option 1 is better. It's the better choice. All right. Our next question and our last question is a bit of a long one here. This was actually an old provincial question, or at least modified from an old provincial question. But it involves many steps. So let's make sure that we rewind the video, pause, rewind if we get stuck, but we're also pausing to make sure we are on the right track as we go along. So we're not just blindly copying things down, we're trying it for ourselves, and then we are playing the video to confirm. All right, so at the age of 30, Alfred began investing $350 monthly into an investment account at an interest rate of 7% compounded monthly. When he turned 45, the interest rate on this investment decreased to 5%, still compounded monthly. Alfred plans to continue making monthly investments until he retires at 58. How much money will Alfred have in his account when he retires? Show your work. Okay, one of the very, very important things that I should be and you should be recognizing when we're reading this question is, first of all, I'm going to be using TVM. I'm calculating something, a value of my investment with compound interest. The only way that we've ever talked to you about this calculation is using TVM. So that should automatically be something that you think of. The second thing that should maybe be a little bit of a red flag for us is we've got 2 interest rates. We've never had 2 interest rates before, and there's not a spot to put those 2 interest rates in a single TVM calculation. So we're actually going to have to split this TVM calculation into 2 parts. Part 1 is going to be from when Alfred is 30 all the way until he's 45, when the interest rate is 7%. And then part 2 from when he's 45 all the way until he retires at 58, when that interest rate is 5%. So we're going to have to do this into 2 segments. So I'm going to split that up, and here's my first segment. So the first 15 years, that's from age 30 to 45, where he gets 7% interest. And then on the next kind of TVM that we're going to do is that's going to tackle the next 13 years from when he is age 45 all the way to 58. And that's when he gets his 5% interest. Hopefully that piece makes sense, that we've never been able to calculate something with 2 interests or interest rates because there's not 2 places to plug in those values. So we have to tackle them separately. All right, taking a look at our first 15 years. Alfred is not making any sort of lump sum investment, so our PV is 0. However, he is making $350 investment monthly. So that's negative $350 for my PMT because it's a repeated payment and it's happening 12 times a year. When we take a look at this, our interest rate is now 7% in those first 15 years, and that's being compounded monthly. It doesn't indicate if he's making that payment at the beginning or the end, so we auto assume end. And we're looking for that final value. We want to know how much he has at the end. I know this isn't the end at 58 when he retires, but the end of our first chunk of time. Now our end value, as we remember, is our PY, which is 12, times the number of years, which in this case is 15, to get us a value of 180. We're going to beep, boop, bop this all into our calculators here, and our final value with the appropriate rounding in units is we get $110,936.80. Now, this isn't our final answer, so I'm not going to box it. I'll just underline it here. But it is part of our answer. Now, like I said before, we have to do TVM in 2 steps because we can't accommodate for that change in interest rate. But Alfred isn't actually taking that money out after the first 15 years. When he's 45 and starting that next chapter of his investment life, when our interest rate is 5%, that $110,936.80 is already in the bank account. So when we're taking a look at our second TVM, that FV is going to start off as my PV. It's going to already be in the account. Now you can almost picture it, if that makes you happier, that at the age of 45, Alfred goes to the bank. He gets that money, that FV, back from my first TVM. He gets that $110,000 and change, and then immediately puts it back into that same account, which now has a lower interest rate. So you could think of that as a new deposit. But that's what's going to happen there. That FV becomes that PV. Everything else essentially remains the same. He's still continuing to invest $350 every month. You're still looking for that future value. It's still compounded monthly. It's still happening at the end of every month. Now the interest rate is 5 instead of 7. And my N is going to change a little bit because my N is my PY, which is 12, times my number of years, which is 13 in this particular time period, which will give me 156 for N. When I plug this in and look for my future value, this is going to be the end result, the amount of money Alfred ends up with after that whole period of time. After the whole entirety of those 28 years. So this, in fact, will be my final answer. All right, just to really quickly recap, we can never do TVM when we have different interest rates unless we do it in multiple steps. TVM does not accommodate a place for us to plug in more than one interest rate. That is why we have to do it in more than one step. If we had 5 different interest rates, we would do it in 5 different steps. If we had 3 different interest rates, we would do it in 3 different steps. But as my interest rates change over time, so does the necessity for me to have more TVMs. Second key thing was my FV for my first TVM value was not taken out and then nothing happened to it evermore. I had to plug that into my second TVM because that money, that $110,000, is still earning interest in his account. He's not withdrawing it. He's not keeping it in a shoebox in his closet. He's not spending it all. He still wants it in that bank, earning interest until he needs it when he retires. So that needs to happen into my PV. All right, part 2 of this question. Now, once he's reached retirement, Alfred, now at 58 years old, he wants to withdraw $2,000 per month from his account after he retires. If the interest remains at 5%, how many months can he withdraw that $2,000 from? Okay. So, at this point, Alfred has $288,905.48 in his bank account. That money is still earning interest and he is leaving it there. He is now no longer investing money every single month because after he's retired, he's not making money every month. The money that he's going to be spending comes from this account. And from this account, he's going to take out $2,000 every single month. Now, we've taken a look at PMT as always a repeated investment so far, but a PMT could also be a repeated withdrawal. So in this case, when he withdraws $2,000 every single month, that's going to be what goes into my PMT. It's going to be positive because it is in fact a withdrawal. It's not an investment. And remember, positive and negatives indicate the flow of that money. And my PV, or Alfred's PV, is going to be that same value from the previous question, that end game value. Now, that money still stays in that bank account because it's still going to earn interest, but I'm just now taking some out every single month. Now, some of the other pieces should be fairly obvious to fill out. So I% is going to be 5. My PY, he's withdrawing that money monthly, so is 12. And it's still at that same interest rate. That interest rate was compounded monthly before, so it's going to stay monthly now. It doesn't indicate if Alfred is withdrawing that money at the beginning or end of every month, so we are going to assume that end point. Now we are taking a look and trying to find how many months he can withdraw that $2,000, essentially until he has no money left. So what that means for our FV is our FV is actually going to stay or could be at 0. Because he is starting off with that $288,000, taking out $2,000 from that every single month. And when is he going to stop? Well, he's going to stop when he runs out of money. So that's why my FV in this case is 0. He's going to keep on withdrawing money until there's $0 left in that account. I am looking for N, not because I want the value of N specifically, but because the number of payments is the only thing that can help me figure out my number of whatever time period I'm interested in, number of years, then converted to number of months, etc. So we're going to go ahead and plug that into our calculator, and we will get an N value of 221.50. Of course, this is a rounded value, but that's what we're going to get. Now, remember that my N value represents my total number of payments. Now, in this case, I'm making payments monthly, right? So if I'm making payments every single month, my N value is actually also going to equal my total number of months. However, if you don't like that explanation and you don't like the fact that it's just going to be the same number in this case, but not necessarily the same number in every other case, depending what time period we're interested in, you are always welcome to determine the number of years from my N value, because I know that N is equal to PY times the number of years. Calculate my number of years and then do a conversion to turn years into months. Okay? So that's always an option that we have. I will show you that option for this one example, but just know that it is unnecessary if you could understand that relationship between N and months when my PY value is 12. All right, so if I was going down this route, I have this value here. I know my PY is 12, and I'm looking for that number of years. To do so, I'm going to divide both sides by 12. When I plug in 221.5 and divide by 12, I get some long number, and that long number is 18.45833333, and that's the number of years that Alfred would be able to withdraw $2,000 from his account for. Now, that's not what the question asks, so I don't really want this as my final answer. what I can do is I could take that exact value, that 18.45833333 years, and perform a unit conversion where my number of years go at the bottom, my months go at the top, because that's the unit I want to end up with, and I plug that in 12, 1, and I multiply that answer by 12, and hey, look, I end up with 221.50 months. Okay, let's talk about that decimal. So that decimal doesn't actually quite work for my final answer. So my final answer shouldn't be 221.5. And the reason that it shouldn't have that 0.5 is because the question doesn't ask how many months will it take for him to reach a final value, a future value of 0, or have $0 left in his account. It says how many months could he withdraw $2,000. Now, for 221 months, he can for sure withdraw that $2,000. But in that 222nd month, he doesn't have quite enough money to make a full withdrawal of $2,000. That is why we can't say that decimal, because it's not halfway through the month he'll be able to make that. It's how many months can he make, or how many times really can he withdraw $2,000 from there. So my final answer should be 221 months. Now, like I said, you might connect that my end value and my final answer in this particular instance are going to be the same. And if you do, fantastic. If you are not sure ever, you are always welcome to do these middle calculations. Sometimes you might find that you get the same answer as what you started off with. And that is okay. But if it helps you feel better for some consistency, that is always an option. Okay. Last but not least, Alfred has a sister, Marianne, who retires at the age of 60. She has a portfolio valued at $200,000, earning 5% interest compounded monthly. If Marianne wants the money to last until she's 85 years old, what is the maximum she can withdraw each month? All right. So we are taking a look again at TVM, and I know it's TVM for a couple of reasons. First of all, we're talking about an investment that's compounded, and that's the only skill we have to deal with compound interest. But also, I'm trying to look at the maximum she can withdraw each month. And hopefully that maximum she can withdraw each month in my head sparks the fact that there's repetition going on. And I'm looking for that PMT. All right, we were going to start filling things out, doing N last, but this is what we've got. 5% is 5. Now that 5% interest is compounded monthly. She has a portfolio of $200,000, so that is in her account right now. She wants to withdraw whatever amount she can do each month. So I know PY is 12. Again, she's going to keep on withdrawing money until she runs out, because this is her retirement savings plan. The whole idea of your retirement savings plan is that you have money to withdraw until, you don't need that money anymore, or until you run out. So we want to see, let's bank on the fact that Marianne plans to live or feed off that money until she's 85 years old. So we want to figure that out. Now, there was no indication when she's withdrawing that money, so the assumption is end here. Now, we need to figure out my N value. N is equal to my PY12 times my number of years. Now, my number of years isn't explicitly given to me in the question, but I know that she wants to be 85 at the end, and she's 60 now, so that difference is 25, which means she would have been withdrawing that money for 25 years. And when I multiply those, I get 3,000. All right. When I'm taking a look, I am going ahead and plugging this into my calculator. I'm getting a payment. I'm going to skip to the final answer with my dollar sign and no negative sign here as well. I shouldn't get a negative sign for PMT just because it is a withdrawal, so I know I should end up with a positive value. But when I plug this in with rounded final answers, I get $1,169.18. All right. And that is it. After this lesson, there is some practice that follows. Please take a look at that. Please give it a go. And then ask any questions as they pop up. All right. That's all for now. Bye.